You know, we used to build our houses out of wood. The wood came from the forest, carefully logged by foresters, and builders would use it to construct homes. Today, our homes are made of concrete, but we'll explore that later. For now, let's focus on wooden houses and why they matter today. It's all connected to carbon. Carbon particles are tiny elements floating in the air, and they're key to how trees grow. Through a process called photosynthesis, trees absorb carbon from the atmosphere using sunlight to turn it into oxygen and stored energy. And that is how forests grow. In simple terms, the more carbon a forest absorbs, the bigger the trees, or the larger the forest becomes. But when wood is burned, all that stored carbon is released back into the air. And this creates a cycle. Forests take in carbon, and when we burn fuel like wood, carbon is released back into the atmosphere. In the past 100 years, we have released more carbon than forests can absorb. This imbalance leads to problems like global warming and climate change. To restore this balance, we need to reduce how much carbon we release and use wood in smarter ways, like building houses to store carbon into the built environment. Every year, the Swiss Federal Office for the Environment publishes numbers about what happens with the wood produced in Switzerland. 59% of the wood is burned for energy production. 22% of the wood is manufactured into wood products such as for construction of houses, and 16% of the wood goes to other uses such as the production of paper and cardboard. So if we want to store more carbon in our built environment, we need to increase this number. And that is what our project MainWood is all about. Now, increasing this 22% is not as simple as it sounds. It takes time and effort from many people and corporations to change systems that have been there for years. Let's delve into some of these challenges. First, reinforced concrete is the current building standard. We know the material very well. It's cheap, it's strong, and it's durable. But producing concrete and iron requires a huge amount of energy and releases a lot of carbon. To significantly increase the wood mass in our building stock, both new buildings and refurbishment of existing buildings must be made of wood instead of concrete. To optimize this, we can expand the lifetime of wood through cascading, where timber is first used as a beam, then recycled into a panel, then used as insulation, and finally processed as cardboard. Second, not all types of wood meet current industry standards. Maybe you're familiar with these tall, needle-bearing trees. They grow quickly and straight, producing long, loose structured wood that's easy to cut, which is why we call it softwood. And this long timber is ideal for building houses. In contrast, hardwoods come from trees with broadleaves. They grow slower with a denser structure and shorter trunks, which produces chunkier wood, which is harder to process into industry standard products. The demand for hardwood in construction is low and sawmills are not equipped to process it. So what happens to hardwood? It's burned for energy production. To increase wood in construction, we could increase the softwood production with plantations. This would stimulate the production of industry-grade wood, but it requires more land and significant policy changes. And this approach might also put our wood supply and wood bioeconomy at risk in the long term, since plantations are more prone to the effects of climate impacts and pests. We could also adapt industry standards to process hardwood. This would involve major investments from industries that are not necessarily returned. Third, increasing wood in construction is not just about changing materials. It requires innovation and collaboration across the system, involving stakeholders of the entire wood supply chain. For example, forest managers will try to balance increased production and climate risks, industries will optimize to process new supplies, government will adopt policies for new land uses, the built environment and promotion campaigns, and financial stakeholders will solidify the wood bioeconomy. There will also be barriers, including existing lobbies, laws and legislations, or the misconception that wood is weaker than concrete, despite decades of innovation proving otherwise. In short, to use more wood in construction, many stakeholders will need to adapt. As you can see, increasing the use of wood in construction goes way beyond carbon capture and storage. It's about our resources, our land use, our politics, and our bioeconomy, each of which play critical roles in our daily lives. MainWood is an interdisciplinary project based in Switzerland, bringing together 10 research groups from 4 different ETH domain institutes. This broad collaboration ensures that we can systematically address the challenges and opportunities across the entire wood supply chain. Through examining how climate change affects the forest management and wood supply, we aim to promote ethical wood production. Through investigating how modern technologies can make wood construction more efficient, durable, and circular, we introduce new design concepts and foster business innovations. And through assessing the values and costs of using wood as a construction material, we aim to support skills development and job creation to make wood a competitive alternative to concrete on a large scale. These transitions in Switzerland will strengthen sustainable local industries like forestry, sawmills, and construction, ultimately benefiting society as a whole.